In this video, I will demonstrate the use of the Influx DB app on ctrlX Core. Influx DB is a time series database that can be used to log data locally on the ctrlX Core. It also features a web-based dashboard to visualize the data, along with alerting and remote messaging capabilities. As of RM2211, released in late 2022, Influx DB has been officially released for ctrlX and is available on the ctrlX App Store. I will primarily use the Node-RED app to push data from the ctrlX data layer into the database, but I will also show an example of doing this with another app called Telegraf. This is the ctrlX Core X3 that I will be using for my demonstration. I will be connected to the top port XF10 with my laptop using the default static IP address of 192.168.1.1, and I will use XF51 to connect to my internet-enabled router to provide internet access to the core when needed. XF51 is set for DHCP by default, so all I have to do is plug it into my router and it will be internet enabled. Let's get started by logging into the ctrlX Core. This core has been set to factory defaults, so we will go through this process from the ground up together. Let's go to Settings, Apps. I am using the System Apps version 1.18 that corresponds to release milestone 22.11. Now let's install the apps we need for this demonstration. Telegraf, Node-RED, and Influx. Okay, the apps have finished installing, and before we go any further, let's check our system time. It's important to make sure that the system time is correct, especially for IoT applications. OPC UA communications will have problems if the system time is incorrect, and the timestamps of the data in the Influx database will be wrong. So I'm going to assign the PC time to the ctrlX Core. Let's also take a look at licenses. All three of the apps we installed require a license to unlock the functionality. In my case, I have a permanent license for Node-RED and Telegraf, and Influx DB is covered by a 3-month trial license that applies to new apps. Notice that the menu on the left has 3 new options corresponding to the apps we just installed. So let's go ahead and launch Influx DB. The first time you open Influx, it will guide you through the initial setup. We create a username, then a password. I will make this the same as the initial password for logging into the ctrlX Core, lowercase Bosch Rexroth. Then we supply an organization name, and this will be used when we connect from the client. and then a bucket name. A bucket is a set of measurements, and we will create one called node red because we will use node red to route the data into InfluxDB in the first step. And that's it for the initial setup. So we have created an organization name, a username, and a bucket. Now we'll use the Node-RED app to pull data from the ctrlX data layer and push it into Influx. And we'll start by adding a data layer subscribe node. And here we set up the device connection. Address is localhost. That's fine because we are subscribing to the data layer of the local ctrlX core. Username and password Bosch-Rexroth. And for name, we'll just call it local core. That's the name of the device. And then we have to give a name to the subscription. Call this local core sub, and we'll use a publishing interval of 100 milliseconds. And now we have to pick something to subscribe to. We'll go into Framework, Metrics, System, and grab CPU utilization %. These are convenient tags for testing because they're always there regardless of the application. And let's add one more while we'll add it. We'll copy and paste this. And for this one, we'll change it to mem used megabytes. And now we'll install the library known as a palette in Node-RED for interacting with the Influx DB. For this part, you need your ctrlX core connected to the internet. So I'm connecting the bottom port of my ctrlX core to my router, which provides the internet connection. Then we're going to go to Manage Palette, Install, and start typing Influx. And this is the one we need. Close this. The newly added nodes show up right here. So we're going to grab an Influx out. We'll configure the server. The version is 2.0. Localhost because it's the local ctrlX core that's running InfluxDB. A token is a unique long string of characters that we're going to get from InfluxDB to make a secure connection between Node-RED and Influx. So click the up arrow from the menu on the left, and then API tokens. We'll generate an API token, all access. Call this Node-RED token. And then we'll copy it. And it makes a point here that this will not be revealed later in Influx. So you have to make sure to paste it wherever you need it. If you don't do that, it's not a big deal. You can generate a new token later. Let's go back and give it a name. And we'll call this local Influx DB. That's the name of the server. Organization, that's going to be Bosch Rexroth. If you didn't remember the exact organization name, you could find that here. And then the bucket. I'm going to rename this. Instead of just node red, I'm going to rename this ctrlX node red, just so it would be clear where it's coming from if we had many other sources of data flowing into this database. Then we have to give it a measurement name. This is the unique name, how we will see this tag show up in Influx. So all this is going to be common, and we're just going to be changing this part for each measurement. So we'll make the connection here, then we'll copy, paste, call this mem used. Now these blocks here are going to be a trigger for writing the value into InfluxDB with these nodes here. So that 100 millisecond publishing rate that we set up is going to mean that we're going to store a new data point into the database every 100 milliseconds. To try it out, we click deploy. Notice how CPU utilization is incrementing about twice as fast as used memory. This is because the data layer nodes only update if there was a change in the data. So if the memory was at 450 megabytes one cycle and remains so 100 milliseconds later, you won't see it increment. CPU utilization is a more dynamic tag than used memory. That's why it's counting up faster. Now let's go back to Influx and see if it's receiving the data. We can see the two tags are showing up here. We'll click on CPU and then submit, and there's the data. Here it's showing us 1 minute worth of data at a resolution of 1 second by default. If we want to see a higher density of data, you can click Custom. I'll put in 100 milliseconds. It matches the publishing rate in Node Red. Now we can see each data point, value, and timestamp. And we can change the duration that's shown in the graph. Now let's click off CPU and click on mem. So there's the memory used. You can have multiple signals in the same graph, but if the scales are a lot different, then it's hard to see the detail. So this is just the Data Explorer to be able to look that you're getting data and what it looks like. The next thing we'll do is make a dashboard. So we'll create dashboard. We'll call this ctrlX. And then we'll add a cell. There's several types of cells or widgets that you can add to the dashboard, including graphs, heat maps, histograms. Single stat is just a text readout. For now we'll stick with graph, and we'll repeat the process that we just did. CPU, and we'll pick the last 5 minutes. And there's our chart on the dashboard. By clicking on the bottom right corner, we can easily resize this to suit our needs. Now let's do the same for memory. We'll pick a different color. And we can also add labels, prefixes, and suffixes. So we'll put megabytes for this one. And let's go back and put percent for CPU utilization. And then we can set an auto refresh. You can go down to 10 seconds from the pull down, but you can type in faster updates if you like. We'll do 5 seconds. And there we have it. So we've completed the first steps to making a dashboard to visualize our data. If you want to move the widgets around, you can simply grab the upper left corner and drag and drop. Now let's say we want to analyze the data more closely. Let's stop the update. Then we can zoom in with the mouse cursor. Left click, hold, drag, and release to zoom in tighter on a certain portion of data. And then you can look at the value of each data point. You can also zoom in vertically as well. Now it might be that instead of looking at the most recent data, you want to look back in time in the database to see what the data was doing when an event occurred on your machine or process. So we can pick custom time range. And edit the start and stop times. And apply. In this way, you may be able to establish correlations between events and the data leading up to the events and set threshold monitors accordingly. Once we're done analyzing, we can go back to the most recent data. Okay, I've added a couple more measurements to InfluxDB. The first one is the temperature of the ctrlX core, just as an example of a slower moving metric that you might want to capture from your machine or process. And for that purpose, I set up a subscription that updates every 10 seconds instead of 100 milliseconds, just to show that you can set up different subscription rates that are appropriate for the type of data that you're capturing and not burden the system by capturing data at a higher frequency than is necessary for the application. And the next is a simulated variable called efficiency. And that's going to be derived from a base value such as 90% plus a random variable just to give the appearance of a real measurement. So here's the random value generator that's going to add to the base value. So this is the efficiency of some process that we're interested in. And we're going to use this as a prop to show the threshold monitoring capabilities of InfluxDB. I've added temperature to the dashboard in the form of a gauge. Now let's add efficiency. And we'll do this as a single stat, which is a text display. And the simplest form of threshold monitoring is just to do a color change based on a threshold. For this example, I'm going to consider an efficiency value greater than 90% to be good, and we'll display that in green. And anything in the 80 to 90% range will be yellow, meaning it's sort of a warning status, something we need to investigate. And anything below 80% will show up as red, meaning there's a critical issue affecting the efficiency of the process. So let's change the base color to something in the red family, and then we'll add a threshold. Say that anything above 80 is going to be a yellow color. And we'll add another threshold. This will be green. And we can apply units as well. And we're linking this to efficiency. I don't see efficiency show up here. Now I see it. And there's where it sits at the moment. Let's add a space in here. Okay, our efficiency is above 90%, so it's showing up in green. Now we can test our thresholds by changing the base value of efficiency. Let's go to 80. And to 70. So that gives us a visual form of threshold monitoring. The next step is to set up alerts, which will log these occurrences as events in the system and also enable us to send out notifications when a threshold is violated. So let's add a threshold check. We'll call this efficiency check. And here we can define the interval at which the check runs. The default is 1 minute. I'm going to change it to 10 seconds. And then that is reflected over here. And then these aggregate functions define how the data is handled in these 10-second windows. For example, we can act on the mean or average of the samples collected during that 10-second window. Or we could act on the max or min. In our case, the min would be the most sensitive setting, meaning that just one sample below our 90% or 80% thresholds will be enough to trigger an alert. And there's several other options here as well. Here we'll define the critical threshold as being 80%. And it has to be below 80%. And then the warning threshold will be below 90%. There's also an informational threshold that you can set that's not considered a warning or a critical alert. And you can explicitly define an area which is considered okay. Otherwise, if the data is not in the critical or warning area, then it's considered to be okay. So you can see our thresholds here. We'll go ahead and submit this. And it's immediately in effect. Our efficiency is currently in the OK range. So I made a few changes to the efficiency. Now let's go look at the history. And here we can see where we exceeded the warning threshold or fell below the warning threshold, and where we fell below the critical threshold, and then where we got back to a healthy or okay status after each event. By looking at this alert history, we can find the timestamps in which thresholds were triggered, and then we could go back to the dashboard and we can look at the data surrounding that point in time, as mentioned earlier, and then see if other data that we're collecting gives us some kind of a clue as to the root cause of the event. We don't have the luxury of staring at a dashboard all day waiting for something to happen, but we have the option to set up notifications so that we receive a message when a threshold violation occurs. The options are Slack, PagerDuty, and HTTP server. Slack is similar to Teams, and I've set up a free account on Slack to test out Influx notifications. So let's create a new notification channel. Then we have to paste in a webhook URL, which is generated from Slack. Next, we have to create a rule which determines when a message is going to be sent out, and also how often. I'll set this for 1 minute. And by default, it's set up to send out a notification only when the critical threshold is triggered. So we'll leave it like that, and then you can edit the text that's sent out. We'll leave this at the default as well. And at this point, as long as we have an internet connection on the ctrlX core, notifications will be sent out. I have my PC connected to the top port, which is XF10, and has a static IP of 192.168.1.1, and I have the bottom port, XF51, connected to the router that provides internet connection. And XF51 is set up by default for DHCP, so all I have to do is have it plugged into the router, and it will be assigned an address and have internet connectivity. Okay, so let's test out our notifications. First, I'll go to Alerts History. So we can see the alerts are being logged here. Now let's check Slack. So I'm receiving notifications in the Slack app, and depending on your browser settings, you can configure this to trigger pop-up notifications in the taskbar. And if you download the Slack app on your phone, you can have pop-up and audible messages on your phone as well. Next, we're going to look at the Telegraf app as an alternative way to pull data from the ctrlX core data layer and push it into Influx DB. Telegraf is a configuration-based app, so you're just editing text files. There's no coding. And there are over 300 plugins available for pulling data from many other sources besides the ctrlX data layer. So we already installed the Telegraf app. To get started, we'll click on Telegraf from the menu and then add Telegraf configuration. We're using this predefined template for connecting between the data layer and Influx DB. Next, we'll edit the configuration. So this section here is for making the connection to Influx DB, and we'll just be populating these fields in much the same way as we set up the connection in Node-RED. So first we'll get a token. Paste it in. Organization name, same as before. Bucket, let's make a new bucket. The next section is for the connection to the data layer. So localhost is fine. If we were connecting to a remote ctrlX core, we would put its IP address here. And then our typical username and password. Here is where we set up the measurements. Telegraf allows you to set up groupings of measurements. So there's one predefined here called metrics, and then one node predefined for CPU utilization. So if we want to add more, we can just copy and paste this format. And then change it as needed. So we'll make this one used memory in megabytes as we did in Node-RED. Since there's no integrated browser in Telegraf, it's handy to use the data layer browser that's part of the main ctrlX web interface. So I'm going to do this in another tab. found what I wanted, so I can click the button to copy the path. Come back over to Telegraf. Paste that in here. And then edit the measurement name. Telegraf has both a publishing interval and a sampling interval. The sampling interval determines how often data is read from the data layer, and the publishing interval determines how often data is written to InfluxDB. And this can be slower than the sampling interval because there is a built-in buffering or queuing mechanism in Telegraf, so it can collect the data and send it in chunks to Influx. I'm going to comment in the sampling interval and set it to 100 milliseconds. This would be essentially replicating what we did in Node-RED, although in Node-RED this setting was actually called the publishing interval. And I'm going to leave the publishing interval and queuing commented out and let Telegraf handle it in the default manner. But if needed, you can comment the publishing interval and the queue size in and adjust to your needs if you find that samples are being dropped. Okay, we're done with the configuration. We're going to save it. And run it. And then we'll go over to Influx and see if we're getting data in our Telegraf bucket. So there's metrics, which is the grouping of measurements. Then we have our CPU utilization and memory used. Do a 100 millisecond interval. And we can see the data looking very much like it does using Node-RED. Sometimes when you click submit, there's no new data, and then eventually it shows again. That's the effect of the buffering. As mentioned, there are many other plugins for Telegraf. The process for using those is you can create a new bucket. For now, just call this test bucket. And then go to Telegraf and create configuration. And you're going to see all the different options of platforms and databases and protocols. When you find what you want, you can continue configuring. And save it. It's going to generate an API token for you. So you may need to paste that somewhere. for future reference. Now I'm going to go back into it and copy. Go over to the Telegraf app, create new configuration, this time I'm not using a template. And then I'll paste what was copied. And as before, you'll put in the credentials to connect to Influx and adjust the other settings as needed for the application. Then save and run the configuration. That's it for this video. Thank you for watching.